Hello. For this particular problem, we are working with double angle identities. And those double angle identities are something that you will have access to. You don't need to have those memorized. But what I do recommend that you do is that you kind of create a formula sheet. A lot of times when I'm looking at the explanation of a problem, I'll click the highlighted or the underlined part and I'll write down whatever that is. So for double angle identities, I would write down what sine of 2x is, what cosine of 2x is, and what tan of 2x is. And on the next slide, I have that for you. But I just want you to know that you don't have to have those memorized. What you have to be able to do is you have to be able to use those and plug those in. And I know a lot of times with trig identities, the thing that student struggles with is the algebra. So I really, I will focus on the algebra here. The directions to this said that we are given that sine of x is 3 over the square root of 10. Okay, sine of x equals 3 over the square root of 10. The other part of this that's important is we are told that x terminates in quadrant 2, okay? It terminates in quadrant 2. And the reason that's important is because that helps us with our positives and our negatives, okay? So it terminates in quadrant 2. And just a reminder, this is quadrant 1, and when we are in quadrant 1, our x value is positive, and our y value is positive. Okay, this is quadrant 2. In quadrant 2, our x value is negative and our y value is positive. This is quadrant 3. Our x value is negative and our y value is negative. Okay, this is quadrant 4. Our x value is positive and our y value is negative. Okay, so that's important to have that when you're dealing with the different quadrants. So that is why knowing where our x terminates is super, super important. Okay, so I'm getting these erased so that we can go to our next portion. There we go. Okay, so I have drawn where our x terminates. So I've drawn this. So here's the beginning, and it's going to right there. This is where our x terminates. So x is the value of this angle right here. Now, with the information that we have, we could find the value of that angle. It would be finding the inverse of that angle. That's not what we're asked to do here, but we could do that. We do have enough information to find the value of that angle. What we're being asked to do is, because we know what sine of x is, we're being asked to find the sine, cosine, and tangent of 2x, and it's using those specific formulas. So the first thing that we're going to do is we're going to look at where x is, and we are going to use our sine of x equals 3 over the square root of 10 to help us with that. Now, you don't need to worry about the x and the y quadrant when we're doing this. What you need to have first is the understanding of what sine x is. So sine is opposite over hypotenuse. Okay, that's what sine is. So this portion right here is 3, because that's opposite, and my hypotenuse is square root of 10. Okay, now we were told that both of these were positive, so we know that that's a positive 3, and we know that square root of 10 is positive. Square root of 10 is the length of the hypotenuse. Okay, now what we need to find is this length right here. That's the length that we're trying to find. Now that will be negative because we're in the second quadrant. That's why this part of your directions is so important, because it says x terminates in quadrant 2. So that means our x value, the length that we're dealing with the adjacent side of x, is going to be negative. Okay, so whatever this value is right here is going to be negative. And that's very, very important. Now, if you think about the Pythagorean theorem, we know that a squared plus b squared equals c squared. Okay? one of our sides of our triangle is 3, and our hypotenuse to the triangle is the square root of 10. So we don't know what this b value is. Now, we're dealing with squares and square roots. So when we're dealing with this right now, we're dealing with that as a positive number. But when we put that over here, because of where it's located on the Cartesian plane, it's got to be negative because that length right there is negative. Okay, so let's go ahead and use the quadratic formula. So I'm going to say 3 squared plus b squared, we don't know what that is yet, equals c squared. So the square root of 10 squared. That's what that means. Okay, 3 squared is 9. B squared, we don't know what that is yet. Now, the square root of 10 squared is 10. Okay, so I'm just going to do a little thing off to the side right here to show you what's going on. We have the square root of 10 times the square root of 10. Okay, that is the square root of 100. The square root of 100 is 10. So anytime that you have something inside a square root sign and you square it, you end up with what's inside of that square root sign. Okay, our next step as we try to find out what b is we subtract 9 from both sides. So we have b squared equals 1. The square root of b squared is b. The square root of 1 is 1. Now, the Pythagorean theorem and distance and everything, we're talking about positive numbers. Because of the location of this reference angle, that's what makes that negative. Okay? Because we're in the second quadrant, that's why that value is negative. And sometimes that's a little hard to understand. Okay, because when we do the Pythagorean theorem, we always get positive numbers. But we are talking about an angle that terminates in quadrant 2. So our horizontal value, what corresponds with our x-axis, has got to be negative. Okay? Okay, now what we have done is we have determined the third side of this triangle. So what we can do with that information, and this is what's going to be needed on the next page, is we can find what cosine of x is and what tangent of x is. So I already know that sine of x is 3 over the square root of 10. Okay, so cosine of x is going to be adjacent over hypotenuse. So that's going to be negative 1 over the square root of 10. And our tangent is opposite over adjacent. So that's going to be 3 over negative 1. And that simplifies to just negative 3. So now, this is the first part of the question where we had to find out the length of that other side. What we're going to do now is going to look at our double angle identities. And again, sometimes it's the algebra that gets students confused with this, okay? So we are going to use the fact that sine of x is 3 over the square root of 10, cosine of x is negative 1 over the square root of 10, tangent of x is negative 3. And that's what we figured out on the screen right before this, is what cosine of x and what tan of x was. And again, our double angle identities, those are given. That's something that anytime you're doing the trig, you're probably going to have written down on a piece of paper. Those aren't things that you're going to have memorized. Now, I will tell you, there are some times that you use them so much that you do start memorizing them. So like the Pythagorean identity, you're going to use that a lot in calculus. And so you may end up just memorizing that. But as far as you having to memorize all these different identities and formulas, you don't. You just need to be able to know what to do with them. Okay, so now at this point, now that we've got this, it really is that we're looking at the algebra again. So for sine of 2x, we're going to have the number 2. So we are multiplying by 2. Our sine of x is 3 over the square root of 10. And then we are going to multiply that by the cosine of x, which is negative 1 over the square root of 10. Okay, now we've got some algebra to deal with so that we can get to our answer here. Okay, there's a couple of different things that you can do. In this situation, I'd probably leave my numerator alone for now, and I would focus on the square root of 10 times the square root of 10. Okay, and we just dealt with that. Square root of 10 times square root of 10 is 10. So what happens at this point, I have 2 times 3 times negative 1 over 10. I just multiplied the square root of 10 times the square root of 10. That's all I did, and I got 10. So now I'm going to simplify. 2 goes into 2 one time, 2 goes into 10 5 times. So my final answer for this is negative 3 in the numerator and positive 5 in the denominator. Okay, and the negative 3 did simplify out with everything in the denominator, but I just want to remind you, you could write that as negative 3 over 5, and a lot of people do. You could even write it as 3 over negative 5. Most people do not write it as 3 over negative 5, but I will tell you that the negative 3 over 5 and the negative 3 in front of the fraction, and then having the negative in front of the fraction, and then having the 3 over the 5 is super helpful. So either one of those is correct. I'm going to leave just this one answer up here. My 5 is a little bit sloppy, so let me fix that. Okay, so your answer is negative 3 over 5. Okay, now we're going to do cosine of 2x. So cosine squared of x. So I'm going to take cosine x and then I'm going to square it. That's what that means right there. So I've got negative 1 over the square root of 10, and I'm squaring it. Okay? Then I've got minus sine squared of x, and that just means sine of x squared. So I am subtracting 3 over the square root of 10 squared. Okay? So negative 1 over the square root of 10 squared. That's going to give me positive 1 over 10, because square root of 10 times square root of 10 is just 10. Then we're going to do negative 3 squared, negative, we're subtracting, okay, and then the 3 is just 3 over square root of 10 squared. 3 squared is 9. Square root of 10 times square root of 10 is 10. Okay, now, fortunately, this is already in a common denominator. Okay, so 1/10 minus 9 over 10 is negative 8 over 10. Okay, and that simplifies to negative 4/5. Now, if for whatever reason you did not have a common denominator here, that would be what you need to do in order to subtract fractions without a common denominator. We were given a common denominator in this situation. There is a chance that in another one you might not have a common denominator. So do go back and remember those skills from early mathematics. Also here we've got a positive number, which is 1 over 10. And think about that as adding a negative number. Okay, subtraction is the addition of the opposite. So we've got positive 1 over 10, negative 9 over 10. The negative 9 over 10 has the greater absolute value, so that's why my answer is negative. Because the signs are opposite, we subtracted those absolute values. That's how I ended up with 8 over 10, or negative 8 over 10. Okay, and then we simplify. 2 goes into both of those. Negative 8 divided by 2 is negative 4. 10 divided by 2 is 5. Just to kind of make sure you see where I did some of that calculation. Okay, now let's do our last one. It's tan of 2x equals 2 tan of x over 1 minus tan squared of x. So we've just got a whole bunch of tangent x's in here. So let's write that down. I've got 2 times negative 3, because the tangent of x is negative 3. Then I have 1 minus tangent of x squared. So that's negative 3 squared. Okay, now I'm just going to draw a little arrow right here because I'm running out of room. 2 times negative 3 is negative 6. Okay, then I've got 1 minus negative 3 squared. Okay, so that becomes 1 minus 9. And I want to talk about some rules right there in just a second. So negative 6 over 1 minus 9 becomes negative 6 over negative 8. Okay, and that is positive 3/4. Okay, so the sine of 2x is negative 3 over 5. Cosine of 2x is negative 4 over 5. Tangent of 2x is 3 over 4. Now, I want to go back right here to this 1 minus negative 3 squared. Now, a very, very common mistake is students will look at these double negatives and say, oh, that's a double negative. I turn it into a positive. Okay? Students do that all the time. The problem with that is that you've got to follow order of operations. And order of operations tells us we have to do exponents first. Before we do anything with multiplication and division, anything with addition and subtraction, we've got to deal with that exponent first. So I actually have to raise that negative 3 to the second power before I deal with this negative at all. That's why you don't eliminate that double negative. If it was just 1 minus negative 3, go for it. You're good. But it's not. It's 1 minus negative 3 squared, and you've got to deal with that squared first. So that's why 1 minus negative 3 squared becomes 1 minus 9. And that's a very common area for students to make mistakes, and I just like to point that out. Okay, as always, if you run into something, let me know, and I'm happy to help any way I can. Talk to you guys soon.